So let's do some examples using this M1V1 equals M2V2 equation that we introduced previously. That M1V1 equals M2V2 equation refers to dilution problems, or determining the concentration or volume of a particular solution after diluting it. Now in this question, it says, let's go ahead and do this question using the M1V1 equals M2V2 equation. I want to know how many milliliters of 3 molar H2SO4, sulfuric acid, are needed to make 450 mils of 10th molar, 0.10 molar sulfuric acid. So reading that equation, I've kind of organized my data down here, and I see that I have an initial concentration of 3 molar. I have a final concentration of 10th molar, and your final concentration in dilution problems will always, always, always be smaller than your initial concentration. I need to make 450 mils of that smaller diluted concentration, so that 450 mils is going to be my final volume. What I'm looking for in this problem is my initial volume of the concentrated solution, or the V1. So I've kind of taken the information in that problem and made a little chart, wrote down my equation of interest, and looking at it, I see that I need to solve for V1. So to solve for V1, I need to take my equation and divide both sides by M1. Now I'm at the point where I can start to substitute in values for my M2, V2, and my M1. And I would note, oh, I gave you the answer already, but I would when putting your values into the equations, I would really recommend you put your units in so you can easily see the units cancel. So the amount of volume of my concentrated 3 molar sulfuric acid that is needed in this problem is 15 mils. And it makes sense that this volume is smaller than the final volume of my diluted solution. It wouldn't make sense if I had to pipette more of my concentrated solution than what my final volume was. So that's a way that you can kind of check yourself. So that's an example of how to use M1V1 equals M2V2 in dilution problems. As I said, your MindTap doesn't use M1V1 equals M2V2. They use C concentrated V concentrated is equal to C diluted V diluted. Both of these mean exactly the same thing. So whichever one you feel more comfortable using. But let's go ahead and we'll use the C and the V in another example. Let's say I need a student dilutes this volume, 28.8 mils of a 7.25 molarity hydrochloric acid solution to a total volume of 100 mils. What is the concentration of the diluted solution? So I am looking for C diluted. Looking at this for the first sentence again, I see I have a volume and a molarity of a concentrated solution. So I have C concentrated and V concentrated. And when it's diluted, that total volume is the volume of the diluted. Okay. So I have my C concentrated as 7.25. My V concentrated is 28.8 mils. My diluted volume is 100 mils. Solve for C diluted. In doing a similar type algebra, I'm going to take the CV equation and divide both sides by V diluted. Plug in my numbers, seeing that my units cancel, and I get a C diluted, or my diluted concentration, is 2.09 molarity. And it makes sense that my diluted concentration is less than my starting concentrated solution. So that's a way that you can check yourself as well. So I could have easily done that problem using the M1V1 equals M2V2 equation. Same setup. regardless of which one that you use, you should feel comfortable being able to use either of those equations in dilution problems. In the next video, we'll talk about our final technique for this chapter with regards to solutions, and those are called titration problems.